Okay, hello and welcome to this Cobalt Institute workshop on our recently launched best practice guideline for sampling, weighing and analysis of semi-refined cobalt hydroxide products. I see we have one person just connecting to audio, so I'll just hold on for a moment. Excellent. So hello again and welcome to this Cobalt Institute workshop on our recently launched best practice guideline for sampling, weighing and analysis of semi-refined cobalt hydroxide products. Please note that we are recording this session so that we might make this available to other stakeholders that are not able to attend either of the workshops today. My name is David Boyle. I am a senior toxicologist at the Cobalt Institute, and as part of my wider role at the CI, I have also led the activities of a working group of our members to develop and now launch this guideline on cobalt hydroxides. In terms of the agenda for this session, in a moment, I will hand over to the president of the Cobalt Institute, Adam McCarthy, who will give an introduction to the Cobalt Institute and explain the background to the guideline project. I will then take you through the content of the guideline, and then I will hand over to Ivo Petrov, Quality Control Manager in the Zinc Copper Department at Glencore, who has kindly agreed to share an industry perspective and insights with us. Ivo is not currently on the call, but we hope he will join shortly. If I could pass over to you, Adam, to give an introduction.
Dave, thank you, and good morning, good afternoon, everybody. As Dave said, I'm just going to say a few words to introduce the Cobalt Institute and also to give a bit of context as to why we developed the guideline. The Cobalt Institute is the global trade association representing the cobalt industry and its value chain. We exist to promote the sustainable and responsible production and use of cobalt. And we do this by acting as a knowledge centre for regulators, governments, industry, the media, public, and anyone else who has an interest in cobalt. We are a membership-driven organisation acting in the collective interest in what we believe is an efficient and cost-effective manner. I think, Marina, next slide, please. Here you see some of our members. We have members from up and down the cobalt value chain, from some of the producers, such as Glencore, who are joining us today, to some of the trading companies and processors, such as Traxys and Umicore, and then some of the downstream users from a number of the cobalt applications, such as battery materials, catalysts, and the heavy metals uses as well. Next slide, please. As I said, we exist to promote the responsible and sustainable production and use of cobalt in all its forms and objectives. Our objectives primarily are to promote and grow the market for cobalt, act as a knowledge centre on cobalt, and ultimately enhance the reputation of the cobalt industry as a responsible sector with a deep expertise in product stewardship of all of our materials. We do this in a number of ways, and on the next slide you'll see how we do this. We work on global chemicals management, ensuring compliance with relevant regulation and legislation. We work on market development to promote the use of cobalt, but also to understand future uses and research and development in the cobalt space. We also work on responsible sourcing with our members to ensure that the concerns around the sourcing of cobalt are being addressed. We also look at sustainability, generating those data which are relevant and necessary to be able to show the environmental impacts of the cobalt industry. And we also work on government affairs and communications to support our work in terms of engaging with those who are making decisions on cobalt and its markets. Turning now to the guideline itself. As part of our remit as an organisation in protecting and growing market access for CI members on a global basis, and to identify, monitor and address the key issues, improve and develop the structures and processes necessary to do so. The development of worldwide industry guidelines, such as this guideline on cobalt hydroxide, are part of this remit, and the standardization of industry measurements of cobalt hydroxide products is key to ensuring accurate market data is available for cobalt volumes originating from operations, and this information is for the benefit of cobalt producers, consumers, recyclers, and traders. Semi-refined cobalt hydroxide products represent the majority of global trade flows for cobalt intermediaries, with much of it originating in the DRC for shipment to refineries in China. With no appropriate standardization methodologies available, the CI has worked with its members, many of them leading companies in the industry who you've seen, develop a best practice guideline for sampling, weighing and analysis of cobalt hydroxides. The overall intention is to promote a standardized sampling and weighing methodology to minimize sampling error, increase the accuracy and precision of measurements to improve the quality and reliability of cobalt hydroxide products for the benefit of the wider industry. So with that introduction and that context, I will hand back to Dave, who will give a much more deeper explanation of the guideline and what in its contents. Thank you.
Thank you very much, Adam, for that introduction. Marina, if you can skip back to the previous slide, please. And one more. Thank you. No, go one further on. Excellent. Thank you very much. So I just want to give a little bit more background here as to why we have a specific focus on cobalt hydroxide products. As Adam has already mentioned, semi-refined cobalt hydroxides account for the great majority of trade in cobalt intermediate products. These products are precipitates. They are filtered and washed and then dried before being packaged into flexible intermediate bulk containers, IBCs, or so-called big bags. Much production is in the DRC, and this material is largely shipped to refineries in China. In terms of the analyses of this material, product quality, specifically focused mostly on cobalt content, is determined from the analysis of representative samples of materials that are subsets of the larger product lot and that reflect the same properties that exist in this product lot, with precision and error in acceptable bounds. Despite analyses on the same product lot often being performed by both producers and users, there is no accepted standard procedure for sampling, weighing and analysis of cobalt hydroxides. Other existing standards, such as ISO for other metal concentrates, are not fit for use with cobalt hydroxides. This is because cobalt hydroxide materials have different and complex physicochemical characteristics. If you can move to the next slide, thank you. In particular, they are physically and chemically heterogeneous. They are susceptible to segregation during shipping and storage, and they are extremely hygroscopic, which means that they have a strong tendency to absorb moisture from the ambient air. What this means is that without full consideration of these properties in a sampling and analysis methodology, gathered samples may not be sufficiently representative of the product lot. Furthermore, these physicochemical properties of the material present challenges for maintaining the composition and integrity of samples during sample handling. And the goal, of course, is such that they should remain representative of the product lot throughout the sampling and analysis process. For cobalt hydroxide products, where two sets of assay results produced independently of each other are required to be exchanged for settlement purposes, it is imperative that each assay is performed according to the same pre-agreed methodology, and this is to decrease the potential influence that a methodology might have on the results. So with these points in mind, the Cobalt Institute, with a working group of Cobalt Institute members, including leading companies in the cobalt industry, have developed a common standardized method based upon shared best practice to gather representative samples of semi-refined cobalt hydroxide products from big bags for subsequent chemical analyses. The guideline covers key steps in the sampling and sample preparation methodology that are acknowledged as primary sources of error in results of measurement of cobalt content in samples. In particular, these include a methodology for how to address loss of mass on drying of the samples. The overall aim of the guideline is to detail the method or a method for collection analysis of samples such that sampling error is minimized and the accuracy and precision of chemical analyses are increased. The figure here at the bottom of this slide shows the steps in sample collection and analysis that are described in this guideline. And now I will say a little bit more on each of these steps so that you have a feel for what's covered within this guideline. So in terms of sampling, best practice is that the sampling scheme should adequately reflect the heterogeneity of the material, and the approach that is used should be duplicated between the counterparties to minimize variability in results from later chemical analyses. The agreed sampling scheme between operators might include references to the numbers of samples to be collected, whether multiple increments of material are to be combined to produce composite bag samples, composite sublot samples, or composite lot samples. If sample increments collected are to be subdivided, the material that is gathered should be homogenized by an appropriate method prior to subdivision of the material. In the guideline, best practice is outlined and is to collect or form 3 samples. 2 for immediate analysis. These are duplicate samples for the analysis of loss of mass on drying, and 1 natural state sample that is to be held in reserve should there be error or dispute that arises between counterparties. In terms of the method for sampling, direction is given that the increments should be drawn from a full cross-section of the bag. This is to account for the possible stratification of the material in big bags during storage or transport. This should be done with a sampling spear or another mechanical device. The best practice is that increments should be gathered from a full vertical profile of the bag and from a natural opening. This best practice recommendation is based on the hazardous properties of the material to be sampled, and the recommendation here is to therefore avoid piercing or otherwise compromising the integrity of the bags. In terms of weighing, samples should be weighed immediately upon collection to 0.1 of a gram using a certified and calibrated commercial balance. The best practice is to weigh directly into a pre-weighed vessel. Samples should be stored and transported in clean and airtight vessels. The suggestion is to use and to weigh directly into aluminium foiled airtight bags with a minimum of airspace. This is to mitigate changes in moisture content. Potential changes in moisture content could decrease the representativeness of the sample to the lot by influencing the measurement of the loss of mass on drying. It is imperative that there is no change in the integrity or composition of the material once the samples have been formed. In terms of the measurement of loss of mass on drying, as mentioned, this has been identified as a critical step within sample handling process. The stored samples should be mixed in the container and immediately weighed. This is to recover moisture that may have been lost to the vessel during storage. and the weighing step can give an indication of the compositional change in the material between sampling and subsequent analyses. The best practice recommendation here is also to not further subdivide the sample prior to analysis of loss of mass on drying, since this practice best enables analysis of the full bag profile and minimizes sample handling, which could otherwise increase the error in the results. Samples should be dried in calibrated commercial ovens at a temperature of 105 degrees Celsius until constant weight is achieved. Constant weight here is defined as when the additional loss of mass between two sample weighings separated by 4 hours is less than 0.1% of the initial sample mass. The sample should be weighed hot to minimize moisture gain from the ambient air during cooling. And again, this is to consider the hygroscopicity of the material. The initial drying period should be 24 hours or a longer, empirically determined and mutually agreed initial period. As mentioned earlier, best practice is to conduct the analysis on 2 duplicate samples with acceptable difference in moisture content of these 2 samples set at less than 0.3%. Once dried, the material should be milled and screened to achieve greater than 95% of the material with a particle size of less than 150 microns. The best practice here is to use a sacrificial sample to determine the milling time to achieve this particle size. The dried subsamples are to be collected into airtight vessels for later chemical analyses. Here, within the guideline, we indicate the best practice is that common samples should be used for both moisture determination and the measurement of cobalt content. The numbers of subsamples to be analyzed for cobalt content should be agreed between the counterparties. This is out of scope of this guideline. Because the samples are hygroscopic, and to address the possible time between sample drying and analyses, subsamples should be dried again for 16 hours prior to chemical analyses and stored in a laboratory desiccator to preserve the dried state. Alternatively, moisture content of the subsample could be determined concurrently with the measurement of cobalt content, for example, by use of a halogen lamp moisture analyzer. The cobalt content of the material is then to be reported on a dry weight basis after correction for the moisture content. Okay, so that is a run through of what is covered within the guideline. Before we open to questions, I would like to invite Ivo Petrov, Quality Control Manager in the Zinc Copper Department at Glencore, who has kindly agreed to share an industry perspective on the use of the guideline at Glencore. If I can pass over to you, Ivo.
I hope you could hear me. I'll be having technical problems, but I have joined from the beginning of the meeting, so I have not missed anything. One of my responsibilities as working as a QC at Glencore International in Switzerland is that I review in every contract, I have to review the clauses related to weighing, sampling, moisture determination, analysis, in this area. And because we are zinc copper department, but we also handle lead, cobalt, molybdenum, and it is very easy for me with zinc, copper, lead, or any of these natural materials who are not chemically modified. There is pretty much when in doubt or when in unknown of how this material will be handled at a certain location, then we simply put the procedure for determining the weight, moisture, and quality and sampling will be in accordance to the appropriate ISO standard. When the cobalt hydroxide business in volume increased, I was presented with a problem because all my questions and searches, I could not find any standard, or as we would like to call it, according to the industry standards. And this was, I find it as a problem. When I review the contract, I could see that a counterparty chose to handle it the certain way, which did not necessarily we would be in agreement with. That brought me to the idea that if Glencore could agree a standard operating procedure with one of the big and reputable companies, that could be of help, as it will be a good starting point. For that, it coincided with our ongoing talks, and that is how we started talking to Umicore. It was a very amicable and professional discussion. We came up with a draft. They came with some remarks. It was quickly agreed and finalized. Later on, there was the idea of creating something on the Cobalt Institute, and so was the workshop the work group has created, and more people from the industry joined. Through this, we presented our standard operating procedure that we've agreed with Umicore. We used it as some sort of a starting point on discussion, and that is how we this is how it evolved to be a guidelines of the Cobalt Institute and the procedure for sampling, weighing, and analysis of cobalt hydroxide, what we have in the moment. This was regarded as a success for ourselves, and since then we've been including it in each and every contract related to cobalt hydroxide. It pretty much comes as simple as that. Thank you very much.
Thank you very much, Ivo, for giving us the perspective of Glencore International. What I'd like to do at this stage is to perhaps open the floor to ask if there are any questions from the attendees of the workshop. Okay, so there doesn't seem to be. Excellent. Okay, so I can see that there is a question in the chat as to when the guidelines come into effect and how will they be promoted. Well, the guidelines have been launched now. Just to be clear, this is a best practice guideline. This is not an international standard. In terms of how they are being promoted, we have launched the guideline already via the website and online. And we will be hosting a further workshop this afternoon so that participants from North America might join. We have also launched the guideline in Mandarin, such that Chinese operators in particular, of course, may find that this guideline is accessible to them as well. And we will look to host a guideline workshop similar to the one you are attending today with a Mandarin translation as well. I see that there was another comment in the chat to see here that given that the chemistry of heterogeneous compounds can be complex, is there any plan for the Cobalt Institute to work with a reference material producer for such hydroxides, as for many years labs have been searching for such materials on which to validate their work? I certainly think this is a possibility. This is something, thank you very much for your questions, that we can take back to the Cobalt Institute members to discuss as to whether that is a possibility. Are there any further questions or comments on the guideline as indicated here in terms of the next step? We very much welcome your comments. Please feel free, of course, to get in touch outside of the workshop because we continue to gather feedback from external stakeholders, and we can, of course, discuss any feedback with the Cobalt Institute members and the working group who developed this guideline. So are there any further questions on the guideline? In terms of the process for feedback, the questions which we will receive, what we intend to do is that we will take those back to the working group, and we anticipate that the guideline is a living document. We consider it to be a living document. Questions and feedback we receive from when the guideline itself is even more widely used by our members, we will then take this back to the working group, and we would anticipate that there will be a launch of version 2 of the guideline to public consultation in early 2022. So as mentioned, please do send your feedback to us. Okay, so there's been a question here that please would you give us an address to send feedback or an email contact. What we can do is we can send a follow-up email to those who have registered to attend the workshops today to provide a direct contact to myself. The generic Cobalt Institute email address is ci@cobaltinstitute.org, and that is included within the guideline document. But we can follow up here to all registered attendees to outline these next steps and ask for your feedback. Do we have any further questions or comments? Okay. Well, if there are no further questions or comments, I would like to take this opportunity to thank you all for attending this workshop this morning. As mentioned, please do get in contact with us and there will be a follow-up email. I'd also like to thank Ivo Petrov from Glencore International for his contributions, and my colleagues at the CI, Adam McCarthy and Marina Demidova, for their roles in these presentations today. So thank you very much for your time. And please do send any further feedback.